What if everything you think about nothing is profoundly wrong? We commonly imagine vast empty space, an absolute void. But what if the deepest insights of physics tell us that true nothingness is, in fact, fundamentally impossible? We tend to imagine nothing as a perfect absolute void. No things, no light, not even the space to put things in, the ultimate blank slate, an infinite emptiness where even time ceases to tick. But what if science, in its deepest explorations of reality, has discovered that this simple idea is impossible? From quantum mechanics to general relativity, the evidence suggests absolute nothing, including space, time, and laws, cannot exist. The universe seems fundamentally biased towards something. Tonight we dive into the unthinkable, a universe where nothing cannot exist. Before we dive into the physics, let us be clear about what we usually mean by nothing. For most of us, the word paints a picture of complete and total absence. Imagine a box. Empty it, suck out the air, remove stray light and heat. Now remove the box itself. A region of empty space remains. To reach philosophical nothing, eliminate space, eliminate time, the absolute void debated for centuries. Even the laws that govern reality, gone. Yet our lives are built on something. Objects, distances, moments. We say, there is nothing in the fridge, though it is full of air, light, and shelves. We call interplanetary space nothing, yet it holds dust, radiation, and gravitational fields. So the stage is set. Intuitive perfect void versus strange findings of modern science. Our first stop is the quantum realm, one of quantum physics' most startling discoveries. Empty space is not empty at all. Even a perfect vacuum buzzes with energy and activity, the quantum vacuum. Not a tranquil void, but a seething cauldron of fleeting particles, measurable, not mere theory. Like a calm sea that up close fizzes with tiny ripples and bubbles, the vacuum is that, everywhere. Pairs of particles and antiparticles pop into existence, then annihilate back into the vacuum, virtual, because they are fleeting. The uncertainty principle allows brief energy fluctuations, tiny loans from the vacuum, quickly repaid. Between closely spaced plates, modes are restricted, creating a pressure difference that pushes them together. Direct evidence the vacuum is not nothing. The restless quantum vacuum leads us to zero-point energy. Even at absolute zero, motion does not vanish. Quantum systems retain irreducible vibrational energy. Zero-point energy is a property of quantum fields permeating space itself. Like a string that never truly rests, fields shimmer with tiny, imperceptible vibrations. Every cubic centimeter of empty space has non-zero energy, a real property. Some estimates make it enormous. A coffee cup of vacuum energy could boil Earth's oceans. If so, gravity should be wildly affected. A puzzle we have not fully solved. Still, the energy is there. The vacuum is not a void, but a reservoir of immense power. If we cleared matter away, could we remove space itself? Enter Einstein. Space as fixed stage, time as universal clock, elegant but wrong. General relativity unites them into a single dynamic continuum, space-time. The fabric can bend, stretch, warp, and ripple. It participates. Space-time tells matter how to move. Matter tells space-time how to curve. Like a rubber sheet dimpled by a heavy ball, nearby paths curve. What we feel is gravity. Space is not a mere container. It has geometry, expands, and carries dynamics. With properties and structure, space-time cannot be nothing. It is something as real as stars and planets. If space-time is real, it should ripple. Predicted a century ago, waves from accelerating masses, especially merging black holes. On September 14, 2015, LIGO heard them. Ripples from a merger 1.3 billion years ago. They stretched and squeezed space by less than a proton's width, yet carried energy across the void. Not waves in something, but waves of space-time itself, proof the fabric lives. The old passive container view collapses under the evidence. If space-time can ripple and warp, it is a dynamic entity with physical properties. It is part of the something of the universe, not the nothing. If empty space is energetic, what birthed the universe? The catchy phrase, "from nothing," misleads, not absolute non-existence. Modern cosmology points to a quantum state, a physical not-nothing, brimming with potential. Cosmic inflation, space ballooned exponentially, from subproton scales to grapefruit size in an instant. Driven by vacuum energy of an inflatant field in a false vacuum, potential energy acting like anti-gravity. As the field rolled down, stored energy became the hot soup of particles, our Big Bang. So the universe emerged from a state with fields, energy, laws, and expanding space-time. A strange but real something. The origin is a transition from one state of something to a richer, more complex state. If not from nothing, can the universe end in nothing? With accelerating expansion, a big freeze, heat death, seems likely. Darker, colder, more diffuse. Stars die, galaxies recede, matter may decay, black holes evaporate, yet not to absolute nothing. A vast space-time remains, with laws intact and the vacuum humming with zero-point activity. Speculative fates, rips, crunches, bounces, still transform something into something. Conservation principles and information suggest total erasure is forbidden. True nothingness appears unattainable. From birth to end, the cosmos seems stuck in a state of being. Existence persists. If true nothing cannot exist, then something is the default state of reality. Why is there something rather than nothing becomes? Why this particular universe? Why these laws and constants? These fields that allow stars, planets, and life? The mystery shifts from the stage's existence to the script being performed on it. Physicists' vacuum means a quantum vacuum full of potential. Philosophers' nothing means absolute non-existence. Science does not solve non-being. It shows non-being seems not physically available to our universe. Existence is robust, not fragile. The cosmos is more bizarre and wonderful than our intuitions. We are part of a universe fundamentally biased toward being, expressions of a cosmos that insists on existing. We have traveled from the fizzing energy of the quantum vacuum to the rippling fabric of space-time, from the fiery birth of the cosmos to its cold, distant future. At every turn, we find the same answer. The void is not vacant. Empty space is a dynamic stage of quantum activity and gravity. Our origin was a transformation of an energetic state, not a leap from non-existence. The ultimate fate appears to be an eternal, low-energy something, not a perfect void. This scientific story redefines our place. We inhabit an inherently active, structured cosmos. Existence is the norm. The grand mystery is why this something has the form it does. The idea that nothing cannot exist reconfigures our understanding of origin, fate, and being. Share your insights below, like and subscribe for more deep dives into the cosmos.